we're going to take a peek today at what grouping is. Now, here's how this works. Grouping problems typically are going to have 4 terms in them. And like I said, I can look at this and I can say, oh, maybe I could take out a y. But then I look, well, the last term doesn't have a y. So I can't take that out. Then you start looking through and you're like, well, maybe these are all divisible by 2. Well, wait a minute, 3 isn't. Well, crap, what am I supposed to do when that happens? So here's how this works. We're going to leave them in the order they're in, except we're going to throw some parentheses around. We're going to group them ourselves. And typically they'll be written in a way that I can do it just in the order they're in. So then what I'm going to do is I just split those into 2 separate problems. And I'm going to see if I can find a GCF in each one. Now, sometimes I may be successful, sometimes I may not be quite so much. But we're going to do that here. So when you look, I did this first one for you. I look at those first 2, and I say, okay, I can divide 2 into each of those. And whether that's using the chart, whether that's using the calculator, whether that's just off the top of my head, if I wasn't sure, I could always go back and say, hey, there's 4 and 6. Okay, so 2 is divisible in there, so there's my 2. And then just like we've said before, it's going to be something as far as a variable term goes. They both have a y. So I take out the one that has the smallest exponent, which would just be the 1. And that's what comes out. And then like what we did before when we were doing these, once I take that 2y out, what do I have to multiply to get it back? What do I times 2 by to get to 6? 3. If I have 1y and I need to get to 2, I need 1 more. Okay? And I just worked my way through. 2 times what gets me to 4? That 2. And I already got my y. Now I look at the second one, like, well, there's nothing they have in common. That's okay. When we see that they have nothing in common, we're just going to take a 1 out, put it in front. You're like, well, 1 times that doesn't change anything, it just gets me that back. That's true. And what I hope what you would notice then is that once I have done my little greatest common factor, that's what left in the parentheses is the exact same thing. And that's the whole idea behind this. It lets us factor it so we could get to an answer like we did before. So I get 2 sets of parentheses for my answer. One of them is the one that's already done for me, because these are the same. And then the other one, I just take the stuff that's outside, my leftovers, I guess you could even say, and you put them together in the other one and you're done. You're like, no, but what's the sense of doing this? Because then, if I wanted to, like what we were doing Friday, I could take each of those sets of parentheses, each of those quantities, and I could go ahead and I could solve those and actually get the answers. And in math, most of the time it's getting to the answer, right? It's to find what solution works. And so by doing this, by changing it around, now I can actually do that. And that's where grouping comes in handy. It allows me the opportunity, if I want to be able to find the solution for that way. But again, it's kind of just pairing them off and doing these mini problems to make this work. But anytime it says factor by grouping, we're just going to pair off what we see. Like I said, in the order they're in already is fine. I look and I go, okay, so if I just start with that first pair, do they have anything in common? Maybe a little something? X. Okay, so I can take out an X. And then my job just becomes to rebuild what I've got in the parentheses. I already have one X. I need to have 2 of them. I need 1 more. Here I have X. I want to get to 2X. Now, not the same way that I did here where X times X is X squared. Okay? Here I already have the X. It's the plus 2 that I need. So if I were to go back and distribute, X x times x is x squared, x times 2 is 2x. I get the same thing back. So I'm hoping now that when I do this to the next one, I get that same set of parentheses. And guess what? I'm gonna. Because I look at these two and I'm like, yeah, x and 2, there's nothing in common there. Oh yeah. I gotta pull out a 1 when nothing else is available. And when I pull out a 1, it doesn't change anything on the inside of my parentheses. But that's okay, because they're the same. That's what I wanted. So for my final answer, the set of parentheses they have in common is half of it. And then all that stuff left on the outside is how I finish it off. So whenever we're doing these, what we're going to attempt to do is always look at each pair and say, okay, there's my one that they have in common. What's it going to look like inside my parentheses on this one? X times what gets me to x squared? You're like, we want to go into write mode. Problem is, when you just write, it doesn't necessarily click as well. X times x is x squared. X times 4 is 4x. Any ideas on what those last two terms have in common? 2. And by taking that 2 out, 2 times what gets me to 2x, x does. 2 times what gets me to 8, 4 does, and look at there. My parentheses are the same, my quantities are the same, which is good. And again, whatever is left over here, whatever my greatest common factors were, they go together too, and I am done. And that really is, let me try to find what's a little bit trickier here. We're going to flip to the back. Want to see if I can find one that, there's the one I wanted. Okay, let's come down to number 5 here. Still going to work at the same. So I look and I go, okay, well, what's so unusual about this one? Well, we're not going to see it until we get to the second set of parentheses here. So 6 and 4, I'm like, okay, I can take out a 2. They both have t, okay. But when I go to get this part set, 2 times 3 gets me to 6. T times t gets me to t squared. And then 2 times what to negative 4? Well, that'd be negative 2. And I already got the t. Now I get to the second one. Here's where life gets interesting. Because at first you're looking like, well, they don't have anything in common. So since they don't have anything in common, I'm just going to go ahead. And Harty said I'm supposed to pull out a +1. And then I copy what's left. But then I look for a minute and I go, uh-oh. These aren't the same. So something's not quite right here, because these are supposed to be the same. And then I take a little closer of a look and I say, hey, the only difference is the signs are switched on the 3t and the 2. Is there a way I can fix that? And the answer is yes, there is. And here's how I can fix it. If I change the sign of the number that I pull out, let's say I make that a -1 instead, that's going to change the signs on both of these. Now this is a positive 3t. Now this is a -2. So now when I go to write my answer, I do have the same thing in the parentheses. And then I just copy with that little change with the -1 in there. And now I am good. So don't let the stuff spook you out. Just because it's not perfect that first time, it doesn't mean something went terribly wrong. Just means we may have to, change a little bit up here. One more here, then I want to help out on some of the homework ones too. Won't go into overkill here. All right, last one, let's pair them off. Look at that first pair, I say, okay, 6 and 8, I think. 6 and 8, that's 2, okay. Get that 2 out of there. They both have an x, okay, I'll take x out. What about y? Oh, wait a minute, they both don't have y. Okay, so just this one. So I just get the 2x. 2 times what gets me to 6? Well, that'd be 3. I've already got my x, but I don't have a y yet, so I'm going to go ahead and I'm going to take that. And then I look and I say, okay, 2 times what gets me to negative 8? That's negative 4, but I already got the x. So again, magic idea, this is the set of parentheses I want when I do this one. So let's see here, 15 and 20. 15 and 20. 15 and 20. 15 and 20. 5. Okay, let's try that out. So 5. 5 times what gets me to 15? That's 3. 5 times what gets me to negative 20? That's negative 4. Nice. And again, the ones that are the same, we just use them. And then I used my greatest common factors for the other. But that's how grouping works. We just pair them off and we're doing mini problems within them to try and make ourselves go a little better. So here's what we're going to do on the factoring worksheet. We're going to tweak this up a little bit. Okay, let me make sure I get my numbers down right. Okay, so we're going to go evens on this one. If some of you got a head start, that's okay. You can get some extra points out of the deal. That's all right. So again, all we're going to be doing on this sheet is just looking through and going, okay, let's find some things we can pair off. Let's find something that looks a little not quite as fun. I'll do an extra creditor here with you. And then I'll let you guys pick out the other one, whether it's an even or an odd, and then I'll let you have a little time to kind of play here. Ooh, 56 and 40. Anybody willing to be brave and take a shot here at what might go into 56 and 40? 8. Nicely done. 56 and 40. 8. All right, so we'll get an 8 out of there. What about my K's? How do I figure out again what I'm taking out for K's? Is it going to be just plain old K? There's a K to the third, there's a K to the second. How do I figure that out again? Always take the smallest one. So we'll take K squared this time, because that's the smallest one I have. And then again, if your thing isn't multiplying, and we've talked about this before, because before we got the 8 with the 56 here, if you go to the other column, that'll tell you how many times 56 divided by 8 is going to be. So I get 7. I got K to the second, I need K to the third, I need one more. 8 times what gets me to 45, and I've already got the K squared, so I don't need any more. But I know that second set of parentheses better equal this, or something didn't go right. So I get to my last group, 21 and 15. What goes in? $21, $15. Okay, 3 does. All right. cut out the 3. 3 times what gets me to 21? That'd be 7. 3 times what gets me to 15? 5. And I see it's negative. Nice. Because again, the ones they have in common. And I'm set. Any others on here look particularly complex that we want to take a together look at here? Which one? 10. All right, to the back we go. All right, let's pair them off. We'll divide and conquer here. All right, 14 and 35. 7. 14 and 35. 7. 7. What about my exponent on my n? Because I see they both have n's. N squared, because that's the smallest one. Nicely played. And then again, it just becomes a little bit of a building thing. 7 times what gets me to 14? That'd be 2. I got n squared. I need to get to the third. And again, the rule is we're adding. So 2 plus what gets me to 3 would be 1. You can put the 1 on there if you'd like. 7 times what gets me to 35? 5. And I've already got the n squared, so I don't need to worry about that. So then plus, what about 16 and 40? Now this one can get a little more interesting because you may notice right away, you're like, hey, 16 and 40, it's 4. But if I go a little further, ooh, excuse me, 16 and 40, 8. We always want to get the biggest one. So we're going to take the biggest one. We're going to take the 8. Because if I'd have done the 4, my parentheses wouldn't have matched, and I'd have known something wasn't quite right anyway. 8 times 2 gets me to 16. 8 times 5 gets me to 40. They're the same, thank goodness. Just copy my greatest common factors for the other. And we're off and running. So again, if nothing else, because now we did one of the homework ones. I only need 7 homework ones. I think the 7 homework ones is just enough to kind of get you situated, see how things are going, and we can kind of